this video, we will be discussing about count vowel strings in ranges. You are given a zero-indexed array of string words and a 2D array of integers queries. Each query, queries of I equals to L, R, ask us to find the number of strings present in the range L to R, both inclusive, of words that start and end with a vowel. Return an array answer of size queries.length, where answer of I is the answer to the ith query. So what they are saying is that in the input, we are given an array of strings, which is words, and another 2D array of integers, which is queries. Right. Now we need to answer these many queries, and for each of the queries, we need to check that. So this is a range, this is denoting L and this is denoting R. So we need to check that within this range in the words, how many strings are there which start with a vowel and end with a vowel, right? So this is 0, 2, right? So from 0 till 2, right? In all these strings, we have to check how many strings are there which are starting and ending with a vowel, and that count will be the answer for this particular query, right? So in the same way, we need to find the answer for all these queries, and that array we need to return as our answer, right? So if we see, this is 0, 2. So from 0 to 2, we have these many strings. Now this first one is starting with a vowel and ending with a vowel, right? So this will be counted. Here this is not starting or ending with a vowel, so this won't be counted. ECE, it is starting and ending with a vowel, so this will be counted. So within this range, we are having two such strings. So the answer for this query will be 2. Then if we check from 1 to 4, so this will be our range. This is not starting and ending with a vowel. This is also, and this is also, right? So there are total 3. Then if we check in this range 1, 1, so this is the string and this is not starting or ending with a vowel. So for this, the answer will be 0. So this is what we need to return, right? So now how are we going to solve this? So the brute force is that for each of the queries, we take the L and R, right? And then in the words, we run a for loop of I starting from L and going till R, right? And then for each of the word, we check that if it is starting and ending with a vowel, then we can count it and we can make it as our answer of that particular query, right? But in that particular case, first you would be running a for loop for all the queries, right? And then for each of the query, you would be running another loop of L to R in words, right? And in the worst case, you would have to travel the entire array of words, right? So if let us suppose that the size of words is m, right, and the size of queries is n, then in that case your loop would be running n cross m times, right? So your time complexity would be order of n cross m. But this maximum can go to 10 to the power 5, and this also can maximum go to 10 to the power 5. So n cross m approach won't work, right? Finding out whether a string is starting and ending with a vowel, that will take constant time, so that won't be counted, right? So now we will have to think of something else. So if you see over here, here we are checking from 0 to 2, right? Then here we are checking from 1 to 4, and then here we are checking from 1 to 1. So we have these repeated strings over here, right? These strings are never going to change. So what we can do is that we can do some pre-computation, right? We can store whether the strings are starting and ending with a vowel or not in such a way that we get the answer for each of the queries in constant time, right? So we can apply prefix sum over here, right? Now how is prefix sum going to help us? So see, in prefix sum, what do we do is, so we will be applying prefix sum over this words array, right? So the size of this prefix sum array will be the size of words array plus 1, right? So here its size is 5. So the size of prefix array will be 6. There will be one additional index at the starting. Why is that so? That we will understand once we build the entire array, right? So at the first index, we keep a 0, right? And then from the next index, we start calculating our prefix sum, right? So these remaining values will correspond to these words, right? So total, the words are 1, 2, 3, 4, 5. So 1, 2, 3, 4, and 5. This will be our prefix sum array. Now in this particular case, for this index value, we will check whether the condition is satisfied for this word or not. If it is satisfied, then whatever is present at the previous index, that value plus 1 we will keep here, right? And if the condition is not satisfied, in that case, whatever is present on the previous index, that is copied to the current index, right? So for this, ABA. This is starting and ending with a vowel, right? So whatever is the previous value, that is 0, we will add a +1 to it, and that will become the value of this index. So it will be 1, right? Then for this, we will check this string. So this is BCB. It is not starting or ending with a vowel. The condition is not satisfied. So in this particular case, whatever is present at the previous index, that will be copied here, right? So 1 will come here. Then we'll check for this. Now this particular string, again here the condition is satisfied. So whatever is present at the previous index, that +1 we will keep here, right? So it will be 2. Then for this, we will check AA, condition is again satisfied, so it will become 3. For this one, we'll check E, condition is satisfied, so we'll store a 4 over here, right? So this is what our prefix array looks like. And if I give the indices, so it will be 0, 1, 2, 3, 4, 5, right? So its size is m plus 1, and initially we can keep all the values as 0, right? So how are you going to build this array? So as I said, its size will be m plus 1, right? And on the 0th index, you will keep a 0. You have given all the values as 0 initially, so this will be 0 anyways, right? So then you can run a for loop of I starting from 1 and going till words dot size plus 1. Basically less than words dot size plus 1. Right now inside this you will check for each of the word, so you will take a current word. Right now if you see the index size starting from 1 over here, because this index is denoting the index of prefix array, but in words array the words are starting from index 0. So what we will do is our current word will be words of I minus 1, right? So for this index we'll check this word, for this index we'll check this word, right? So we will get the current word over here. Now we can check that if the condition is satisfied, if the condition is true for this current word, right? So in that particular case, for the current index in the prefix sum, we will take whatever is the value on the previous index and we will add a +1 to it, right? Else, whatever is present at the previous index, we will copy it as is to the current index, right? So with this, we will be able to build this particular prefix sum array, right? And if you see here, we are just running a loop equals to m times, basically the number of words that we have plus 1. Plus 1 is a constant, so we can say m times, right? Now, how are we going to identify our answer with the help of this prefix sum array, right? So we need to answer these many queries, right? So what we will do is that we will create an array answer of size equal to the queries. So here we are having 3 queries, so the size will be 3, right? Now we will take the first query. This is L and this is R, right? L is 0, R is 2. So basically we need to check this particular range which corresponds to this in our prefix sum array, right? Now for checking this range, how many strings are there which are satisfying our condition? What do we do is that whatever is the value present at this particular index, basically whatever is the value present for this particular string, we take that value and we subtract it with a value present at an index previous to this string, right? So for this range, for this string, we will take this value, right? And for the starting, we will take this particular value. And for that reason, we have kept a 0 index over here. And if I do 2 minus 0, so it will be 2. So this 2 denotes that in this particular range, there are 2 strings that are satisfying our condition, which is this string and this string, right? If let us suppose you want to check this particular range. Now in this, the answer has to be 2, right? So how you will identify? For this, the value is 3. And then for the starting, you will check the value corresponding to this string. So that is 1. So 3 minus 1, that is 2. So there were 2 strings that were satisfying our condition, right? So for the first query, we have L as 0 and R as 2, right? Our range is this, right? But now if you see here, the indexes have become +1, right? For 0, we have a 1 and for 2, we have a 3, right? So firstly, we have to consider L plus 1 and R plus 1 inside the prefix, right? So L plus 1 will be 1 and R plus 1 will be 3. So yes, we are considering this range, right? But then for identifying our answer, we were doing the subtraction of this particular number or the index and this particular index, right? The index just to the left of L, right? So R plus 1 will remain as is, but instead of L plus 1, we will be considering the previous index, which is L plus 1 minus 1, right? And it can be written as L only. right? So basically for each of the queries in the prefix sum array, we will be considering r plus 1 and l, right? So if you see in 0 comma 2, L is 0, R is 2. So we will be considering R plus 1, that is 3, which is this particular index, and L0, that is this particular index. So 2 minus 0 will be 2. So the answer of this query will be 2. Then let's check for this one. So here L will be 1 and R will be R plus 1, which is 5, right? So 4 minus 1, that is 3. So the answer of this query will be 3. Then for this L is 1, R is 1. So R plus 1 will be 2 and L is 1, right? So 1 minus 1, that is 0. So the answer will be 0, right? So this is how we can identify our answer. And here if you see, we will be running a for loop for these queries, right? We will run a for loop of I starting from 0 till the queries dot size. I'm writing Q over here denoting the queries, right? And then for each of the queries, we will be taking L and R and our answer. In our answer at the index I, we will store whatever is present in the prefix sum at the index R plus 1 minus whatever is present at the index L, right? And this will give us the answer of each of the queries. And here we are only running one for loop equal to the size of queries, which is n, right? So we will say that the overall time complexity of our code will be order of m plus n, right? This m for building this prefix sum array and this plus n for finding out the answer, right? And for the space complexity, we have taken this extra prefix sum array, which is equals to the number of words, right, which is m. Plus 1 is a constant, so this is m. So we can say space complexity will be order of n, right? So let's quickly look at the code for this approach. So first of all, let's create an answer vector which will be equals to the size of queries. So queries dot size, and then let's create an unordered set, right? In this unordered set, we will have our vowels, right? With the help of this, we will be able to identify whether the condition is satisfied for a particular string or not. So we have kept all the 5 vowels A, E, I, O, U in our set, right? Then we will create another vector for our prefix sum. Let's name it P. Its size will be words dot size plus 1 comma 0. Initially, we will have all the values as 0, right? Now we will run a for loop of I starting from 1 and going till words dot size plus 1. And then we'll do I plus plus. Now inside this, we will take the current word. So the current word will be words of I minus 1, right? Now we need to check if the condition is satisfied for this word or not. So for that, what we can do is that in this current word, we can check if its first letter is present in this set and the last letter is also present in the set, right? If these two conditions are satisfied, then that means it is starting and ending with a vowel, right? So what we'll do over here is that vowels dot count the 0th index of current, right? And vowels dot count in the current the last index, current dot size minus 1. So if this condition is satisfied, then at the current index, we'll take the value of the previous index and we'll do a plus 1. Else, we will copy whatever is present on the previous index, right? Then we need to identify the answer for each of the queries. So we will run a for loop of I starting from 0 and it will go till queries dot size and then we'll do I plus plus. Now inside this RL will be queries of I of 0, right? And R will be queries of I of 1, right? And answer to the ith query will be in the prefix sum the value at index R plus 1 minus in the prefix sum the value present at index L. And at the end we can return this answer. Let's run this. The test cases are accepted. Let's try to submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.